Hey, sixth graders. We're going to continue our journey through the islands of functions today, the function archipelago. So today we are going to look at a second part about functions and tables, which is to look at what's my rule. You've been looking at what's my rule tables since you were very little. They show up a lot in everyday math, in your math boxes and things like that. So if you've done math boxes in other classes, you've done what's my rule tables. And they can be pretty easy. They can also be incredibly hard. But we're going to start looking at how to use them in algebra. So what's my rule is really a function. And a function is a machine. You'll see other teachers explain it this way too. Function machines are tools that we use in algebra, and they help us solve problems. When we use function machines, they have three pieces. They have the input, that is the thing you put into the machine. They have the output, that's the thing that comes out of the machine. And then they have the rule. And the rule is what turns the input into the output. Rules can be very simple. Rules can be very complicated. But we use them to help us solve problems. So a good picture of an example is the function machine like this. The input goes in the top, the rule changes it, and out comes a number at the end. Yeah, this is very similar to what I was just saying. So the rule goes in, the input is the number that goes into the machine, 4. 4 is the machine that goes into it, or the number that goes into it. The rule works on that number, so 2x minus 5, x being standing for any number that you put into the machine. So in this case, 2x minus 5 means 2 times 4 minus 5. 2 times 4 is 8. 8 minus 5 is 3. So the function has worked on that 4 and done something with it and spits out a 3 as the answer. But we could use any number for x. It doesn't necessarily have to just be 4. It could be a lot of things. It could vary, and that's what we discovered yesterday, is we learned that it could be lots of different numbers, which is why we use the variable to stand for any number. So up to now, we've been using n when we solve for algebra. But when we really transition into function machines, we need to start looking at it from a new point of view. And that new point of view is looking at it with new variables. So now we have two things to keep track of. We don't just have n. We have an input and we have an output, which means we need new variables to keep track of them with. N is no longer sufficient. So what we're going to do is we're going to call the input, the number that goes into the machine, x, and we're going to call the output, the number that comes out of the machine, y. So y is kind of like our answer, and x is kind of like the example, the question, the situation that we're creating by putting that number in. So what does this mean for us? Well, let's give it a try. Let's see. Here's an example. Here is a function. This function says that y, the output, the answer, is equal to 3 times x, 3x. So whatever I put into there, I'm going to get out another answer, but I'm not looking for one answer anymore. Now I am looking for all of the answers, all of the possible answers. I'm looking for a series of answers that create a pattern, and that pattern is 3 times that number. So I could pick a whole bunch of numbers, and I'm going to get a whole bunch of answers, but they're all going to be related to 3 times those numbers that I picked. Let's look at it. It's always easier to see than it is to hear. So let's look at this in a table form. Y equals 3x. And we looked at a table yesterday a little bit. So let's look at this. If the input is x and the rule is 3 times x, then the output is going to be the answer I get when I take the x and I multiply it by 3. So if I pick 0 to be my input, then I'm going to do 3 times 0. And my output then is going to be 3 times 0, which is 0. Wow, exciting. Amazing stuff, right? Sure, not the most exciting thing in the world, but it does give us an incredible amount of power for making predictions. Because remember, I'm not looking for one answer anymore. I'm looking for all of the possible answers. So I'm also looking for 1. So I'm looking for 3 times 1, and that is 3. And I'm looking for 2, and that is 3 times 2, and that is 6. And I'm looking for 3, and that is 3 times 3, and that is 9. And I can keep going and going and going. And you're going to start to see that there is a pattern here that is growing as I go by 3 each time. And that allows me to make predictions about where it's going to go. Now, this is a pretty simple example. We also can have more complicated examples. In this case, we're going to have y, our output, is equal to 4x, that's 4 times our input, plus 2. So again, we're going to have our input x, there's our rule, 4x plus 2, or y equals 4x plus 2, excuse me, that's our function. And then our output is going to equal to y. So in this case, it's 4 times 0 plus 2, 4 times 0 being 0, plus 2 is 2. 1 is going to be 4 times 1 plus 2, that's 6. 2 is going to be 4 times 2 plus 2, that's 10. And we're going to keep going. Well, what do you notice about these numbers? These numbers are creating a pattern as they go. And the pattern can be predicted. And the pattern can be predicted, which is really neat. So let's look at this. Let's look at how the pattern is predictable. Let me think here. Here we go. All right, so let's look at this. We know that it is 4 times our x. So we're multiplying times our x. But look at what happens as we look at the pattern here. How far apart are these? They're 4. How far apart are these? Also 4. And if we notice, the pattern continues to go. It is continuing to go up by 4 each time. Oops, sorry. Hard to write on a trackpad. So it's going up by 4, by 4, by 4. Now, but the answers are always 2 bigger than that 4 times. But this right here, this is the key, because this can be used, in fact, to work the other direction. And let's look at an example of that. So what if I gave you the table instead? So I'm not giving you the rule, but I'm going to give you the table, and I'm going to ask you to find out what the rule is. Ooh, that can be tough. You had some practice at it, and in this case, it's kind of easy, because we can look at it and say, well, 0 times something is 0, and 1 times something is 9, and 2 times something is 18, and 3 times something is 27. And you know that if you multiply each of these by 9, if you know your 9 times table, this is pretty easy to figure out. It's just times 9. But how do we write that? The key is that we have to write it like a function. So what we have to do is we have to make sure that we're writing the full thing. That means the output and the input are included. So in this case, it is y equals 9x. That means 9 times the input. This answer right here is going to equal 9 times whatever you choose to put into it. So we can make a prediction. What's it going to be when x is 10? Well, it's going to be 90, because we know what the rule is. All right, this one's pretty easy, but notice again that this pattern follows very similar to what we talked about in the last one. Whoops, that's not the pointer I want. Excuse me. That's the one I want. It's still going up by 9. Going up by 9. And that's key, because this right here, how much it's going up by every time, is going to be a consistent number, and it's going to be the number that I am multiplying times x. So in order to figure this out, what we need to do is look at how much it's changing each time, and that's the part that is being multiplied times x. Let's try another one, see if we can do it here. All right. Remember, we're going to use the pattern to help us. So in order to figure this out, we're going to have to use the pattern in the numbers. So let's look at it. How much is it going up by? When it's 0, we've got 1. When it's 1, we've got 4, and then 7. I notice that it's going up 3 here, and it's going up by 3 here, and it's going up by 3 here, and that's a pretty consistent pattern. The pattern says, oh gosh, it's going up by 3. So that means whatever my answer is going to be, it's going to include a 3 x, because 3 times these numbers, 3 times 1, 3 times 2, 3 times 3, 3 times 4, those numbers are going to create this pattern of going up by 3s. But that can't be everything, because if we notice, 1 times 3 is not 4, it's 3. And 2 times 3 is not 7, it's 6. So what is being done to these numbers to create the final number? Something else is being done. Something is being added to it. Well, in this case, it's pretty clear that the answer is 1. 1 is being added, because 3 times 1 is 3, plus 1 is 4, 2 times 3 is 6, plus 1 is 7. But I'm going to show you a trick that is really, really, really helpful. If we look at the 0 case, that is, when x equals 0, then it's really easy to figure out what that plus, or in some cases minus, might be. Because 0 makes, if I make this 0, if I make x 0, then I do 3 times 0, that's 0. Okay, so whatever is left over, 1 in this case, has to be that extra piece that's being added to the number. So look at the 0. Whatever that number happens to be, that is what is being added to our pattern of numbers. So we're looking for two things. I'm looking for what is the pattern, and then I'm looking for what does that pattern say when x equals 0. Now remember, when you do this, you need to write out the whole thing. You need to write y equals 3x, because that's our pattern right here. 3x, because it's going up by 3, plus 1, because it's always adding 1 to that 3 that we have. So our function is 3 times x plus 1, or y equals 3x plus 1. Let's look at one last one, because I want to really drive home this idea. Once you know the trick, once you know how to spot the patterns, this can be done very, very, very quickly. So again, let's look at this one, and let's look at the pattern, and then let's look at the plus or the minus at the end. So the first thing I notice is that this is going up from -3 to 3. That goes -2, -1, 0, 1, 2, 3. That's going up by 6. And from 3 to 9, again, that's 6. And from 9 to 15, that's 6. So my answer must include a 6 times x. Remember to include the y equals. So y equals 6 times x, but that's not all of it, because 6 times 1 is not 3, it is 6. So what is the part that comes after? What is this part right here? Well, this part right here we can get by looking at the 0. The 0 is, in this case, -3. That means I start at 0 and go down 3, which means I must be subtracting. Well, I can just take this number and I can just put it on the end, because I know that I'm going to subtract 3 in order to get to that spot. So my full function is y equals 6x minus 3. And there it is, 6x minus 3. So we're going to do two things today. You're going to make tables. You're going to take the function and turn it into a whole big table. And then I'm going to give you a table, and I'm going to ask you to turn it into the rule, the function. And you're going to do that by looking at the pattern involved in these numbers and how much they're growing by. And then you're going to look at the 0 case, and you're going to figure out what it's saying about that function in that spot. If you are stuck and you need help, please come see me in the Google Meet. I would love to help you today.